yourself. Good afternoon, everyone. I'm Bob Nadell of Energy and Lighting System, also of LEDucation. Today, I think we're going to have a very interesting discussion. I'm not exactly sure. I was speaking to Lindsay, trying to understand it, but I guess we'll all be very well informed in just a few minutes. Lindsay is a technology and design strategist with a keen sense of lighting applications. She has over 2 decades of experience in an array of environments, large multinational corporations, startups, and design collectives. Lindsay is a former professional member of the IALD, is LC certified, and possesses formal training in lighting and architecture with a master's degree in lighting design from Parsons School of Design, where she later went on to be an instructor. I'm sorry, that's my bad. I should never allow that to happen. She later went on to become an instructor at Parsons. She holds an MBA from the California State University and is the Director of Product Management of iLighting International, a subsidiary of Iwasaki. She is constantly exploring the boundaries of lighting, connectivity, and social impact in our digital age. For those of you who want AIA credits, you will sign up at the front desk. We would love to hear some feedback from you. Go to LEDucation.org and put in your comments. We would love to be able to do more programs like this, and your input will make it happen. So thank you very much, and without further ado, Lindsay. And my apologies.
Okay, good afternoon. So the title of my talk is Human-Machine Interaction, which is a big subject. So obviously, I'm not going to go into every aspect of human-machine interaction. But I also thought the title was a little playful, but maybe playfully pretentious. So, and has a little mystery to it. But anyway, there's a thread that comes back to you. So just bear with me. These are sort of slides, AIA. I think you've seen these. Anyway, I'm not going to go through them. Some of the learning objectives, these are requirements of AIA. And, but let's just get started. So human-computer interaction is basically what it sounds like, the study of how humans interact with computers. And there's different ways to interact. There's passive interaction and active interaction. So a passive interaction might be something like you're in an airport and video cameras are watching you and there's video analytics going on and they're crunching the data. You know that, right? That happens, right? So, and then active interaction would just be like punching in your PIN number when you go do online banking. So, so there's different types of interaction. And certainly a lot of the passive interactivity is a big focus of a lot of what's going on in many industries, not only in lighting. So does anybody know this fellow? His name is Norbert Wiener, or Norbert Wiener, whatever. And he was a mathematician and a philosopher, and also a professor at MIT, just basically a super smart guy. And he is credited with the term cybernetics. Has anybody heard of cybernetics? Not Dianetics, cybernetics. So cybernetics is, it has to do with human control functions and how artificial systems could possibly replace them. So, and this was, quite a while ago that this study this whole field of study arose. And it actually kind of predates him, but he was the one to sort of make it a kind of a field of study. And again, he was a mathematician and a philosopher, so he's dealing with numbers, but he's also dealing with behavior. So basically, it's the overlap of how computer systems and biology, like where they overlap, right? And so in terms of human-computer interaction, it sounds, a little bit lofty, and maybe you think, oh, that doesn't have to do with my profession, etc. But it does, right? So human-computer interaction deals with computer science, behavioral science, and design. So as a designer, you are touching all of these. So it's very relevant to your practice. And does anybody know who this guy is? Lots of quizzes here. Come on, you architects out there. So his name is Carlo Ratti, and he's the director of the MIT Sensible Cities Lab. Have you heard of that? Also a really smart guy. But also, he's an architect, and they deal with how cities will be shaped by technology, etc. But one of the things that he really talks about is how designers can influence that. So he has a term, it's called futurecraft. And futurecraft is not predicting the future, but influencing it positively. So we're not passive in this whole development of smart cities. We can be active. We can influence it. It can be daunting to think about all of it, but it's something that definitely he espouses there at MIT. And I just want to read a little. This is a book that he wrote with another fellow, Matthew Claudel. It's very interesting. It's called The City of Tomorrow: Sensors, Networks, Hackers, and the Future of Urban Life. So it's a great book. And if you're into that. So one of the things he says in this book is, just as smartphones are a portal to larger systems, architecture can function as a mediator between daily human-scale functions and vast humanity-scale networks. So that's from this book. And so another humanity-scale network that you're probably familiar with is Uber. So I just want to give an example about how people can influence the way, or not influence, the way sort of technology enters our lives, our industries, our professions. So I don't know if you're aware of this, but Uber many years ago approached the New York City Taxi Commission and wanted to collaborate. And the New York City Taxi Commission just thought they were isolated from any competition. So they said, no, we don't want to work with you. And you know how that ends, right? So they became a tremendous competitor, where in actuality they were approached to be a collaborator, right? So another industry, I'm just using some examples of things, how they became electronic. So in litigation, there's certain evidence that's kept, and lawyers read tons of documents, and those were always paper documents. And as time went by, it became digitized, and it became ESI, electronically stored information. So this market around e-discovery, the software and all the services behind it just grew exponentially and became a $9.8 billion industry. So very quickly. And of course, yeah, there were some lawyers who said, no, I don't want to have anything to do with this. But they have no choice, or they're going to really fall behind. So There's a lot of different forces that are going on, but there are ways to collaborate, influence, etc. So this comes when is in related to lighting, right? We have smart lighting, which means so many things. It's very loaded, and I'm not going to go into that. But what makes a device smart? What happens when you make a device smart? So there's new goods and services, consulting opportunities, the ability for non-industry players to gain access. So I'm sure on the last bullet, as lighting practitioners, you've heard sort of several doom and gloom premonitions about like how it will be irrelevant lighting consultants, and Google will come over and do all the lighting and etc. So I'm not going to go into the doom and gloom stories or predictions. I actually believe in the opposite, right? That there are many, many new opportunities that didn't exist before. So, but that takes a certain amount of education, right? Or awareness, or at least openness to the possibilities. And what I mean by this is you don't necessarily have to go out and get a computer science degree, but there are some basic sort of principles of information technology that are the basis of wireless lighting control systems, no matter what they are. They all kind of follow basic tenets of IT. So there's no way you can be an expert on every wireless control system out there. It's impossible, and they all have different names, and one company will call one thing, piece of hardware, one thing, and the other company will call it that, etc. So you can never become an expert on all of them, but you can definitely learn just sort of what's happening in its basic sense, right? And in its basic sense, the lighting system is a data transmission system. That's really what it's doing. And I think that the more you learn about these things, the more trust your client is going to have in you. And trust, no matter it's the digital age and everything's taking over and automated and da-da-da, trust is still something that can't be commodified. So it's as a consultant, it's part of what you sell, right? Your trust. So as far as everybody knows what IoT is, right? And I'm not going to go into like sort of all the bits and parts of what it is, but basically it's kind of where the cyber world and the physical world come together, right? So they're physical devices, and they're talking to each other, and you're aware of them, your Fitbit, your refrigerator, your blah, blah, blah. So, yeah. So, and then, of course, you hear a lot about the IoT and IoT of lighting and et cetera, et cetera. But basically, IoT is like a network of networks talking with physical devices and sensors. You may think like, well, how does this relate to you, IoT? I mean, of course, on your personal level, I'm sure you have many consumer devices that are IoT, right? But on your professional level, in your job, how does it relate to you? And I have another pop quiz. Nobody's getting my quiz answers, but does anybody know who that is? Come on.
Can't see.
It's Motoko Ishii. Does anybody know who she is? Anyway, she's a legendary lighting designer, sort of one of the forefathers of lighting design. She practiced in the 1960s and in Japan. And she's also was an amazing businesswoman, basically a big trailblazer, right? So this is a woman in the 1960s in Japan, when there wasn't really an architectural lighting profession. So you know, she's a badass. Let's put it that way. So, but in her day, you know, she didn't have to think about IoT, right? But for you, you do. There's a lot of ways that this, yeah, of course, relates to you on a personal level, but in a professional level, it relates to you because lighting control systems, like I said, are basically data systems, and data being passed around. It's sort of the data is like the raw material, right? So, you know, you have to wonder, well, where is this data? So here's just sort of, this is a diagram which is sort of the encapsulation of what IoT is. Physical sensing, cyberspace, actual information data. So your physical sensing, it could be an occupancy sensor. And cyberspace could be the cloud that's computing the data, and then the information is sent out to the light, do this, do that, etc. So we're dealing, you know, with lighting, you have physical objects, right, the lighting fixtures, and you have data transmission, and then you have the actual light, which is a particle and a wave, so you can figure out where you want to put it down there. There's a lot going on there, and all of this relates to you. So again, I think if we approach lighting control systems and we just look at it that way and we try to compare apples to apples, it's very difficult. But if we look at them as data systems, it's a little bit easier to break down, in my opinion. So in terms of data processing, again, this is just any data in any information system, lighting, whatever. There's your input stage, and that's where data is being sent, being encoded. The processing stage is sort of all the crunching and you know, figuring out, like the cloud it's just a bunch of computers crunching data. And then they're transforming the data, the raw data, into information, and then output, so decrypting, etc. And then there's storing the data, right? And then retrieving it. So these are just basic ideas of, basic tenets of data processing. So yeah, the cloud. The cloud's not like some esoteric mastermind. It's just a bunch of servers, right, in many different places. That's really all it is. But when you put all of this computing power together, you can enable, you know, ubiquitous computing and a lot quicker information than any sort of standalone system. And they're just a bunch of brains put together, and they're duplicatable, so if one fails, the other one can take over. So this also allows like data mining, and I mentioned ubiquitous computing, etc. So yeah, the cloud. So a network is basically when one thing can talk to another thing, or several things. So a network could be open, it could be closed, and security is the way that you sort of block certain channels of communication, also in encryption. So there's, like I said, this is just the same principle of a wireless lighting control system. This is what it's operating on. So there's structure. So okay, another buzzword. I'm into buzzwords today. Big data. What's big data? A lot of data, yeah. So it's like so much data that a regular computer system cannot analyze, right? It's just lots and lots of data. That's all it means, big data. And then there's structured and unstructured data. So structured data would be, say, a system where there's an established database that can be queried. So, you know, you go into your Outlook, you want to find an email from your mom, and you just put in her name. And then unstructured data is where there's no way that, you know, in a normal query system that you can interpret any of that data. So in big data, I'm sure you've heard about, you know, the things of predictive analytics, et cetera. So that's dealing with unstructured data and how to interpret that. So I would say, you know, kind of at this point in lighting systems, we're mostly dealing with structured data, but as lighting systems become intertwined with building systems or even urban systems, then you're getting into unstructured data and analytics. So, and I wouldn't, in a way, you know, you sort of don't have to become experts in data analytics, but I think it's just important to know that there's a lot of data there that you may not see as useful, or your client, but it could be in the future if it's put together with other data, and then there is a way to interpret the data. And the business of interpreting the data is a whole new industry that's just growing exponentially, right? Okay, so where does the data go? And why do you care? Well, I think you should care because if you're specifying something for your client, you should kind of know where the data goes. So I want to kind of put this as a metaphor like a car. So the roads are the network, right? And then the car is the carrier. And then the people inside are the data. So the car has, say, two IDs, and this is the same thing with the device on a network system. So you have a MAC address and an IP address, right? So that's how you know where to go, right? Where the data is going. So your MAC address is like the VIN number on your car. It's attached to hardware. It doesn't change, right? And then the IP address would be like the license plate. So and then the data are like the people, and they speak all different languages. So but that's a nice way to remember kind of MAC address, IP address. And again, you don't have to know every, you know, sort of term of IT, but there are some essential terms that I think are important. But also it's sort of understanding direction and where things go. You know, in electricity, it's more basic, but this is electronics, so it gets more complicated and reconfigurable, et cetera, et cetera. So I'm not going to kind of go into this too deeply, but in terms of data processing, there's telemetry, which has to do with how information flows. Telemetry, just think of telepathy, you know. And then inquiries, when you're asking a question to the system, commands, telling that light to dim to 5%, and notifications could be energy usage on a device. So again, these concepts are just basic IT concepts, but they apply to lighting controls. As far as network configurations, there's many different ways that your lighting system can be connected or not. So, for example, you can have an isolated lighting network that is not connected to the internet or not connected to the building management system. You can have a lighting system that's connected to the building management system, also connected to the internet. There's different configurations. So, is connectivity always the best thing? It's kind of like asking, is being alone always a good thing? Well, sometimes it is. You want to have some time on your own, but then sometimes you want to spend some time with other people, and there's certain benefits. And also certain risks, right? But when you're by yourself, you have a little bit less risk. But so there's all different things involved. But definitely always being connected to everything else is not always the answer. So it kind of depends. So for example, I think of like a municipal like baseball field. It has its own lighting system, wireless lighting system, but that system is not connected to the whole infrastructure of the civic lighting system. And it can only be controlled, in proximity to the baseball field. And that could be a good thing. It all depends on what the situation is. So it's important to think about not only when you're specifying a lighting system, but how it connects to, or doesn't, to the other systems. So here's there's a couple diagrams. So in this first diagram, the lighting system is connected to a gateway. The BMS is connected to a gateway. So the gateway is sort of like the brains, the processing. There's some processing happening at the fixture too, but the main processing is happening at the gateway. So in this case, they're both connected to the internet. The lighting system may be able to access the BMS, vice versa. It all depends on, sort of the permissions and how the system is set up. In this system, the lighting is only connected to the internet through the BMS. So if the BMS system were to go down, the connection to the internet for the lighting system would go down. And then in this section was sort of like that scenario I said about the baseball field. It's on its own, and the BMS is something else. So, and then in this instance, you have a smartphone that's able to kind of give commands to the lighting system, the BMS system. And in terms of how those cross, then that has to do with programming and permissions, et cetera. So there's all different types of ways, but this is sort of, I guess, the basics. And then protocols, right? Many protocols. So protocol is really a system of rules how data is communicated, right? So it's like a language. And I go to a lot of conferences and I'm in committees and everyone's like, oh, why can't we have just one wireless protocol? And, So it's, I use the example of like Esperanto, it was a great idea, but it didn't really catch on. It couldn't do it all. Not to say that there who knows, there may be one protocol that will rise to the top and become like the new sort of standard, but at this point there is no Esperanto. And I'm not going to go into the reasons why. There's various reasons, technically and market-wise. So that brings me to protocols for building management. So even if you're in lighting, you should at least be familiar with some of what these protocols are. So you're a consultant, I used to be a lighting designer for many years. So you're in meetings with, HVAC, plumbing, security, fire protection, everybody. So you're talking about how everything interacts. And, the building management system is obviously a big thing. And so BACnet, right? You've heard of BACnet. That's in the US, that's kind of the most common protocol for building management systems, like telling the elevator, fire suppression, blah, blah, blah. And then there's LawnWorks and Modbus, so those are some other ones. I would say BACnet's the most common. And then for lighting, I have a couple up here, but there's definitely a lot more too. So there's Bluetooth, TCP/IP, Z-Wave, VLC, Visual Light Communication, ArtNet, and then Zigbee and Snap, which are based on the IEEE 804.15, if you're interested in reading that. So, and even Zigbee is not it's kind of a standard, but kind of not, because one Zigbee device doesn't necessarily communicate with another Zigbee device. It depends on how it's configured, and also the firmware in the Zigbee devices. So even Zigbee is not, it's sort of, it doesn't have just one way of communicating. So, but never fear, you'll figure all of this out. As I said, if you're thinking about sort of the basics of data transmission, it's going to be a lot easier to understand. IMO. Okay, so mesh networking. I'm sure you're going to be hearing a lot about mesh networking. It's basically when the system topology where one node can speak to another node and that node can talk to another one. So if you have a bunch of nodes and then you have a gateway, which is the processor, you could scale up your system by adding other nodes without having to add another gateway, because they all talk to each other, and then if one fails, they sort of fill in. So it's almost like that's how it works in the cloud as well. So mesh networking, yay. Okay, so data concerns. So lots of data concerns, as I'm sure you know. Of course, there's security, and I'm not going to go into the sort of details of how to encrypt and blah, 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 blah. There's a lot of people who know about that, but there's other things that are concerning besides just hacking. It's just knowing, where is the data? Like, do you ever think about that? So your lighting system is collecting all this information. Like, where is it? It's probably a good idea to know for your client. And who accesses it? Where is it stored? How long is it stored? So I think for your client, these are important things to know. And they may not even know to ask you, but you should ask yourself. So, for example, if you're in a meeting, for a building, and you got the IT consultant, and you got the electrical engineer has the panels laid out and the circuiting, and then IT guy has his IT system and the wiring. So that's the physical view of the network topology. But then there's also the data view. So just because it's wired in that one on the left doesn't mean that that actually is the only way it communicates, right? There's other ways that communicate. So the physical view and the logical view. And again, you don't have to memorize all this, but you should know when you look at the drawings of the IT infrastructure that it's not like electricity, right? It just flows on a wire. It doesn't work like that. So your digital footprint, this is something you're familiar with, right? You're on Facebook, you go to a restaurant and you say, I'm at this restaurant. It gets posted and then it's like forever there, right? You leave a footprint. But you also have another footprint that you leave. It's metadata. So metadata is basically data about data. So you have, in this example, I have a book and the card catalog. So the book, the contents of the book are that's the data. And then the metadata would be like, where is it published, blah, 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 Library of Congress number. That's metadata. So even when you take a photo, the JPEG that's on your phone, for example, has metadata attached to it. So it's not just the pixels of the image. There's metadata attached to it. So, so your footprint it's like the footprint of the footprint. And this is sort of and again, I'm not trying to make everybody scared and whatever, but as far as like legality, there's ways, how information is stored. So 34B is a section of the Federal Rules for Civil Procedure in litigation for electronically stored information, like how it's stored, how it's retrieved, so it can be upheld in court. And so this is just a super basic map. So in this litigation case, you have Mr. Smith and Mrs. Jones. Oh, that's another quiz. Does anybody know that song? Mrs. Jones? Okay. Okay, he does. Okay, so somebody got my quiz answer right. All right. So you have, going across, so you have the custodian, Mr. Smith, Mrs. Jones. And then they had computers. These were their computers. They work for some company and, they're in litigation. And then you may make a map of when the data existed, and then they also had an iPhone, etc. So it's an evidence map, right? So I just put this together for lighting. I've never seen one before, but kind of just made it up. But it could be interesting or subderivative of this for you to create for your client. It's sort of like, okay, there's a control system, and under that could be like BACnet or, lighting control system, etc. And then in the column that says devices, I guess you can't see from there, right? Oh, they should move this screen over here, but. So the column that says devices, you can have whatever devices are connected to that, the gateway, the BMS, blah, blah, blah. So where does the data reside? Does it reside in the gateway controller? Does it reside in the cloud, right? Or there it says AWS. Does anybody know what that is? That's Amazon Web Services, which is the pretty much the biggest provider of cloud storage. So a lot of wireless control systems, they'll say, oh, we have cloud computing, we can host you. But they're basically probably renting it from Amazon, which is not a bad thing. It's probably more secure than your own server in your own office, right? But that's what AWS is. So then in the next column, it says, like, how long is the data accessible? So, like, if my light is sensing occupancy, like, how long do I have to keep the data, And then who can access the data? So maybe you have certain systems where you're saying, oh, only the building manager or blah, blah, blah. You could put that on there. And then the other one is about encryption. So is it encrypted, that data? So this is just an example I just made up. It's, like I said, I've never seen one before, but could be a good idea to at least, kind of document this stuff. And you can maybe do it in your own way of how you want to do it. So these are some important questions I think people should ask when they're thinking about a wireless system, like, is it connected to the internet? Maybe. Is it behind the firewall? Are there security measures in place? Should I perform penetration testing? Does anybody know what that is? Another quiz. So basically, penetration testing is for your system is you set up your system and then you try to hack into it, right? And that can also be for hardware. So hardware has software attached to it. It's called firmware. So you can hack into hardware too, or you can hack into the whole system. So penetration testing is, basically hacking into your own system. And for if you have a really big job that's complex and you feel nervous about what you're recommending to your client, you might want to hire somebody who does penetration testing or pen testing. And then about communications, are they encrypted, right? That's very important. Okay, so I'm really into phenomenology, which I'm not going to talk about today, but Maurice Merleau-Ponty is a phenomenologist. So he said, we know not through our intellect, but through our experience. So again, you don't have to be an expert in all of IT, but you have to kind of go on your, the experience that you've gathered. And you shouldn't just be afraid like, oh God, I don't want to put this wireless system and I'm going to be open to liability, because you can't really stop the wave. Just, it's going to happen. But just ask questions, and like any other thing you've recommended, look into it, find out. And in the beginning I talked about human-computer interaction and how it sort of overlaps behavior, design, computer science. So in your field, I see this overlap of, the lived experience, technology, and light. So you are definitely, practitioners of human-computer interaction. And so I have some key takeaways. One is, network ecosystem, it contains diagnostic information, but also user activity, right? So investigate, document how lighting connects to building management systems or other systems. This is very important. And who will and what will control the data flow, right? So those are definitely important. And like I said, just ask questions. If you're in a team meeting with other consultants, it's better to ask than to just think like, oh, this is over my head. Just ask. And I like reading, so this is there's a book I read, Industries of the Future. And there's one quote in here that I just wanted to kind of end off, is land was the raw material of the agricultural age. Iron was the raw material of the industrial age. Data is the raw material of the information age. Okay, that's it. Does anybody have any questions? No? Okay.
How do you see things like voice control really influencing the future of the lighting industry?
Of lighting?
It's a completely different form of interaction.
Yeah, I mean, voice control will improve. Right now, for any kind of technology, it's not quite there. But once it improves, yeah, it'll definitely be relevant. But now it's still a little wonky, right? So, but certainly. Anybody else? No cyborgs out there that? Oh, okay.
I know there's some light now is equipped with a camera inside it for the smart device, like measuring light and the human's behavior or something like that. But do you see any discussion about legally or something? Because it's even some lights even though those camera status would not provide customer, it is for the internal analysis or something like that. But
You know, yeah, that's a great question, because those are all sensors in there. And I was at Strategies in Light a couple weeks ago, and the CEO of Enlighted, which is kind of the biggest IoT lighting device company, I asked him that, like, do you see any trends in, or not trends, or how do you deal with the legal aspect? And he said, that's a great question. We need to get on the... So that's actually something that I've been looking into a lot myself, because there are no kind of guidelines about those things. So yeah, it's important, and it's something I'm looking into. So maybe at the next LEDucation I'll have some more information about that.
Right, because that's even been an issue at lower tech levels of lighting. I remember hearing from a colleague about a GSA project where they didn't want lighting controls over each cubicle,
Yeah,
because then managers might start tracking more when people were in and out.
yeah, or how long they went to the bathroom or
Right,
something. Yeah.
things like that as a way.
TMI. Okay.
Right, so, whereas on the other hand, handing off information about how often conference rooms get used or something like that is.
Yeah.
So it definitely is, a consideration of how we,
Yeah.
work and what what those end users are.
Mm-hmm. For sure. Yep. Anybody else? Okay, thank you.